Technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main.
So welcome. This is going to be a quick lesson on basically IP phone boot up. That's what we call in the VoIP department, right? In our voice department. We are basically network engineers that specialize in voice technology and VoIP technology. And VoIP is voice over IP, right? So it's voice that's carrying, that's being transmitted through internet. Okay. So basically what I've learned is you learn basically how the IP phones get connected to the network, and then you learn how to make an outbound call, and then you learn inbound calling. And then once you learn the high level of those three things, you're able to dive deep into calls, into hardware, and to other things to get your head wrapped around, becoming and working in Cisco telephony, right? And really what it's about is it's about you understanding how the network works at a whole before you come over here and learn about how the how voice networks work, because we're just expounding on our networking knowledge, and we're just putting it in one lane, which is that voice lane. Okay, so we'll be talking about VLANs and other networking protocol, TCP, UDP, TFTP, things and that such. And you really wouldn't understand unless you've already taken that first part of like the CCNA, or even went through the CCNA like exam topics. And then you can kind of understand the high level terms that we're going to use here in this lesson. Now I am like you guys know, I am part of the voice network, the voice department. And again, I got my start by understanding these three things. And then I just went deep into it. And, I ended up working in the field. Okay. So I'm really just teaching you guys how I learned, how I started. So you can, get your foot in the door and start the same way. All right. Now this information right here, as far as PDF, as far as the notes, the resources, it's all going to be a part of the computer science bootcamp. I would suggest definitely get involved in that, definitely become part of the team so you can get these resources. Now, this video, I'm going to show everyone. I'm going to upload it to YouTube, upload it to Facebook, all the social medias. So you guys can get this information and learn for free if you want. All right. So let's get into it here. We have IP phone boot up. Let's actually make this a full page. And this is, again, like the start of it. Now, you will see some terms here that you're probably not familiar with. Most of these terms, I'm going to say 90% of these terms are discussed in the CCNA exam track. So please review that. I wouldn't say, you don't have to go get your CCNA, but definitely go through that exam track, those exam topics, so you can understand what's happening. Okay. Now, when a IP phone boot up is, again, basically just the IP phone, the internet protocol phone that operates with internet connectivity capabilities. This phone needs to be connected to the network. So how do we connect it to the network? What's the communication path? And as we can see, we have it, and I've made this diagram right here. So I'm going to walk you through it, and we're going to start at like 1, 2, 3. We're going to go in order. So as you can see over here on the left, we have 1, which is the administrator. So you're probably a remote network engineer, and you're working on your laptop from the comfort of your home, right? So what you have to do as a network engineer, and most of the time, these are like tier 1 network engineers or junior network engineers that could do this process, is they would gather the information of the IP phone so they can upload it to our servers. So the administrator, if you look over here to the right, number 1, the administrator has to configure the phone in what we call call manager, or you see the acronym CUCM, which is Collaborative Unified Communication Manager, right? It's just a server that houses all the information of our device, right? And that information will include MAC address, right? That is the physical address of that IP phone. A setting called device pools, which is, common of that phone, and device security profile, and a phone button template, right? You can kind of, understand what those are from a high level. And the administrator will gather this information and upload it to our call manager server. Okay, so once that's all uploaded, the phone is now on the server. The phone now needs power. It needs power so it can get through the network to even access the server to say, yes, this is who I am. These settings are correct. Okay, so number 2 is all about giving the phone power. So the administrator has all the configurations. Now they're going to go to give the phone power. And how do you do that? Now there's 3 ways. You can do it by a power patch panel, which is like a device that allows you to gain power, plug it into the outlet, or a power brick, which we all have. You have a computer, then, you need a power brick to make sure that your computer doesn't die, right? We all have that, a power supply. And then the most commonly one that we use is PoE, which is power over Ethernet. And what we do is we connect the phone by an Ethernet cable to a switch, an L2 switch, right? We talked about that in the CCNA track. And that switch has enough power because it is plugged into the outlet already. And it has enough power to power up the phone, to give the phone enough power. And they'll allocate that power based on that phone type and the switch type as well. And there are a couple protocols that I listed here under 2. We have 802.3AF, 802.3AT, 802.3BT, right? And there's different wattages of these protocols that will allow, certain numbers, certain wattages of, power to get to the phone. And that's just what you configure. Again, we went to the CCNA track. We learned about the protocol 802.1, 802.3, right? Ethernet protocol. So now the phone has power. It's good. It's great. Now we want to make sure we see we're at 2. We want to go up, and now the phone needs to hit the switch. The phone has power. It's going to go to the switch. What is going to do? The switch needs to know VLANs. We talked about VLANs. So we either going to do a voice VLAN or a data VLAN. So we're dealing with a phone. So what VLAN do you think we're going to do then? It's a voice VLAN. So we're going to configure that. We did that already, so this should be a breeze for you. The 4th one, let me go back up. My bad, you guys. So the phone has power. It went to the switch and now knows what VLAN it needs to use to carry this traffic. Now the switch is going to be connected to the router, right? So now the switch is connected to the router, and the router needs, what we have to configure is a IP helper address. Now that's going to go in tandem with the DHCP server. We talked about DHCP server. Why do we need a DHCP server? Because a DHCP server is going to allocate IP addresses to the network. So when your device, whether it's a computer or a phone, connects to the network, the phone or the computer is going to say, I need an IP address so I can start transmitting data, throughout the network and outside of the network. I need an address to use. And so instead of us as the administrators sitting there doing it one by one to, assign IP addresses, we have an automatic system, which is DHCP. It'll do that tedious work for us and say, hey, here's your IP address and here's some other parameters, right? So we want to make sure that the phone and the computer, well, in this case, just the phone, can get to this DHCP server to get the IP address it needs to start transmitting this phone call outside of its own network, right? Because we want to call, let's say we're a salesperson, we want to call different types of prospects. So they're not going to be in the company, and they probably not even going to be in the same state. So how do we do that? Again, we need an IP address, and that DHCP server is going to do that. Now, we need a way to that DHCP server, and the only way to do that is to ride on the back of what's called an IP helper address. The IP helper address will say, hey, I know you don't have an IP address, so let me just route your packet, let me route your messages to the DHCP server so y'all can talk. And you can get what you need so you can talk to everyone else on this network. Okay, so boom, we went ahead, configured IP helper address on the sub interface, which is, a like a virtual instance of an interface. And the phone is able to gather its information to do what it needs to do. It's at the router, it goes to DHCP server, gets the, IP address, subnet mask, all that good stuff. The main thing we worry about as voice engineers is ensuring that this phone gets a TFTP option 150 or 66 from DHCP, right? That's something that we're going to configure on the DHCP server, make sure it's check marked and say, hey, I want you to provide a TFTP option, which is the TFTP address. Now, what is TFTP? That is Trivial File Transfer Protocol. It is a server that allows you to house information, files, and someone you can access this server and just gather files that you need, whatever those files may be. But that server is specifically just for files like configurations or things in that such. So the DHCP server is giving the phone all those parameters plus a way to get to this TFTP server. Okay. So now everything's good. From 5, as you can see right here at this DHCP, it went all the way down to number 2, which is the user phone. User phone got all the information, okay? And if we look here on the right at number 5, it got most of this information. This is the information that we care about. IP address, subnet mask, default gateway, the DN domain name, the server, and then TFTP, the option, which is, again, a way to it. Now it has that information. It's now going to route to the TFTP server because that's what DHCP said, go here next. So it went to the server and it's basically made sure that the configs were correct. It got the MAC address, it got the firmware, it got the device pools, if you can see all the configurations, everything that the phone needs to go ahead and operate and start registering to our call manager, our main call source, our main call control source. Now it, has all the information, it has all this configuration. It now goes to, again, we have our call manager, which is our main call control source. Now that call manager is going to say, hey, are you going to register from 2 different protocols? Is it SIP, SIP, or is it SCCP, which we call skinny? One of these 2 is going to register to our call manager, which is our main call processing server. Now we can start, receiving calls, making calls, and just, we'll hear a dial tone. Okay. Now that's all of it in a high level. Now, if we scroll down here, it goes in just a little bit, which I kind of want to show you guys some pictures and some things that give you like a visual of this whole process that we talked about quickly. So like I said, IP phone boot up, we want to make sure that the phone gets to, get added to the network. It's configured to the network, and it starts with us as the administrator. So as the administrator, we have to gather some information so we can get this IP phone to the network. So let's see what we have to do here. We have to get the MAC address, the device pool, device security profile, and the phone button template. Let's take a look. We have the MAC address, okay? So the first thing we have to do is we have to get one of these phones and we have to find the MAC address. What is the MAC address? It is the physical address of the phone. It is, comprised of unique number and the manufacturers put together, and it says, this is a unique address for this device. Okay, every device has its own unique MAC address. Now on this iPhone, it has its own unique MAC address. We can find it either on the box where, the packaging where it came shipped in. We can find it on the back or on the bottom of the phone. And we can actually go inside of these settings in the phone and find the MAC address. Now, this is something that you would do, let's say you're adding in one phone. But again, you want to think on an enterprise level. So we would be configuring probably 300 phones at a time or 1,000 phones at a time. So in that case, we would use what's called a BAT tool, right? It is called a bulk administration tool. And this tool basically just allows us to add all the information, all of the information of the device into like a CSV. And we can like get a scanner and just scan the back of the phone. It'll just pop up in this Excel if it's a bunch of phones, like 300 or something. Or, maybe you'll have to copy and paste. It's a lot of different ways. And again, tier one of or junior network engineer will most likely do these tasks because they're very tedious. And, you know, if you're more on the engineering as far as like knowing how to develop the infrastructure, then you're probably going to be needed somewhere else. So to get your start as a junior, you'll definitely be doing, you know, tedious tasks as using the BAT tool. So yeah, so you have your CSV file uploaded, 300 phone, the MAC address, you know, probably put the numbers in, probably put a caller ID in, a whole bunch of other things. And you would save that, and you will upload that to Call Manager, right? Our CUCM. And our Call Manager, again, is that main call controller, okay? So we have that uploaded. Now everything is good. We can do it one by one, but like I said, that's very tedious and you'll probably be doing that forever. But the MAC address is the first thing you are getting as an administrator. If you take a look at this phone right here, this is a pretty common phone. It's a Cisco IP phone, 7900 series. We work with these a lot. 7900, 7800, and probably the 8800 series. So I would definitely suggest that if you go on this track, to start looking up different models of Cisco IP phones, because they're all different in the environment that you use. But this is the most common, this series, right? So let's go back to your admin duties. So we have the Mac, it's uploaded. Now what we have to do is configure our device pool. Our device pool are common settings for a group of devices in a specific location. So think of it as though like Atlanta branch, Houston branch, Minnesota branch, right? They all are in its own device pool because they all have, you know, they're in the same location and they all have certain settings according to that location. For instance, date and time group. You know, Houston is going to have a different date and time than Atlanta, than Minnesota, right? So again, we're creating these device pools for, you can say, each branch in our company. So each device pool will have a date and time group. So we'll say, this is the time zone, Central, Eastern, Mountain, whatever. You choose a format. It's defaulted at 24-hour, but we are US, so we use a 12-hour format. So make sure you change it to that. And then date format, again, we are US, we do things different. So it's month, date, day, and then the year. Others, they use the day first or they use the year first. So again, working on Cisco, with being a Cisco engineer, that's worldwide. So you may actually deal with branches that are, excuse me, not in US. They may be in a different country. They may be, you know, across in Australia or something. So you have to be mindful of understanding the dates and times. A call manager group, we have to configure that, which is really just a top-down list, right? A list that says go here first, go here second, go here third, of servers or nodes, you can say, that the phone can register to. So our phone can register to our first one, which is our primary. And let's just say something goes wrong with our primary server. Now the phone can have a backup and go to our secondary. You know, we have a list and it's 3. So, you know, we can figure that later on. But continuing on, we have to configure our locations and regions. Locations means that this is the max amount of bandwidth that we can have over a WAN link. What is WAN? A wide area network. The WAN is like the internet. The WAN connects all LANs, right? All local areas together. So when we talk about a WAN, that means that we must want to travel outside of our network to the internet, quote unquote. So that is the amount of bandwidth that we can have to travel these voice calls over this, you know, internet link. Okay, so our service provider will give us that information, but we know that we can only allocate 60% to voice only. Okay, everything else can be data. And let's just say we don't have enough bandwidth. We can always use things like AAR, which is automated alternate routing. So, you know, we can route our calls over the internet, which is like our ISDN, excuse me, or we can route our calls over the PSTN. And the PSTN is dedicated lines for telephones, right? But we're audio, we're VoIP, we're voice over internet protocol. So we're making sure that we can route our audio calls over the use of internet. And again, if that doesn't work, then yes, we'll revert back to the dinosaur days, which is the telephone poles, right? So that's locations, and we have to, again, configure that. And that actually gets configured in tandem with the regions. And regions is the max bandwidth per call. So instead of, the amount of bandwidth we can have for voice calls in general, we now have to set up how much we can do per call. And that kind of goes in with a little bit of knowing codecs. Codecs is CODEC, which is nothing but compression and decompression. So you kind of, what they're doing is they're compressing the audio, making it, compressed to where it can travel, and not take up a lot of bandwidth. And then when it gets to its destination, which is the other phone, it will now decompress and actually come out and utilize those resources. We have a couple of different codecs that you would have to drill in your head, which is G711 and G729. These two codecs, they're really defaulted, especially if you're working on a lot of American projects. But again, they're just ensuring that your audio can be compressed and then travel over the internet and then decompressed when it gets to the receiver. And then it's going to do the same thing. And that's going to happen with its resources. So when I say resources, you can think of something as little as hold music. So when you're calling, let's say you're calling AT&T because your bill is too high, then you're listening. They're like, let me put you on hold. And it's those are resources that's being compressed over, the internet to, you, and decompressed, and you can hear it. And then, of course, you're going to send something back out with your voice. And then, it's going to be compressed, traveled over the internet, and then decompressed at the receiver's line. Okay. And again, this is all done with these protocols, which is G711 and G729. Okay. I'm not going to get too deep into the math of it as far as the differences and such, because that's really what voice is about. Voice is about just going deeper into regions, deeper into locations, call managers, device pools in general. So there's no need to learn everything right now up front, because that's just what your whole career is going to be. And that's why people like voice a lot, or probably more over data, because it's very confined and you just need to know only this information. But the information is so deep that it's like you never get to the end of it, because it's always going to not only change, but there's always new information that, you probably just didn't know, because again, we're very specific. We're honing in on just the audio, right? So just moving on here, what else we have to configure in device pools? SRST, survivable remote site telephony, which is basically saying that if something goes down, we have a way to route your call processing, basically just your audio, again, to the telephone poles. We are routing over the internet. So if something goes down, if our internet goes down, we can still make calls by using telephone poles. Okay. You probably can't check your email, but we can still make calls. So that's kind of what, SRST is. It's just a, redundancy, just a fallback protocol. And then we have our MARGOs, right? Our media resource group list. That's basically, again, just media resources. So like I said, music on hold, conference call, if you wanted to add in a third party, that's a media resource. So that uses extra resources, and we have to configure those as well. Okay. And here's a little drawing, a little picture here. Just like we said, device pools are location based. So we have a New York device pool. They're going to have their own configurations with everything we just talked about. And it's going to traverse over the WAN. And let's say they want to talk to London, London people. They have their own device pool. And then Paris over here, they have their own device pool. They have their own configurations. So you would literally have to set up device pools for each location. So again, if you work in a company and they're doing like some merger and acquisition, and then they're, setting up new sites and, 30 different states, then, you have 30 different device pools that you have to create. And again, a lot of times that's handed down to the junior network engineer or tier 1. Or maybe that's just you as tier 2 or tier 3. That's just your busy work until you get called upon to do something else. So that's pretty like copy and paste work that can keep you busy for months, even a year. So device pool, MAC address. Another thing is device security profile. So we click on that, and device security profile is exactly what it sounds like. It is the security of the device. It's just a certain profile that's related. It's just a group, related settings. So we can just click on this group and put the phones in this group to, secure the device. And call manager, I said this, main call processor is looks something like this. You'll go, it's like a website, and we call it a GUI, because you can utilize call manager as a GUI, which is, a graphical user interface like such, or you can access it through the CLI line. So you can actually go onto a router and just, go onto the server, and access that through, the CLI. You can just run commands and, do the same stuff that we're doing now. It's just, who wants to? We like a pretty interface, and we like to click save and delete and copy and stuff. So this is where we would go. This is where you go normally. And a lot of things are restricted in the CLI as well. So you have to be in here most of the time. But this is really what it looks like. And in this section specifically, it's for the phone security profile. And, we're just, again, clicking on the profile that we created, making sure the settings are correct, and we just click save. Okay. And then we're going into each user, and we're just literally saying that this is the profile they're going to use. Okay. And lastly, we have our phone button template. Again, sounds just like what it is. It's the buttons on the phone. We're just saying, hey, this is what this button is going to do. Either it's a programmable, a customizable button, so you can add your own speed dials, or maybe we put that button to where you can call support, or you can call your manager, or I don't know, whatever they want us to put. And on the phones, as you can see, this is kind of like a 7900 series. You have the buttons and you have the soft keys, right? These are the soft keys. We can, again, configure it how we want, how they want us to, or how the architect, says that it needs to be. So yeah, you're just saying what the buttons are. Most of the time, they're forward on the same department. So customer service has the same buttons, HR have the same buttons, managers may have the same buttons. And once you configure those buttons, you're literally just putting this template to every phone. You're adding that template to every phone, Again, a lot of copy and paste, a lot of just, put this here, put that there, just so it can, go to the next stage. It's just, you need to know the reason why we're doing that, because once you understand the rhyme and the reason, then it's easy for you to copy and paste, right? It becomes an easy job, but you, again, have to understand it. Now, administrator, that's all you're doing. That's all we did. All we did was make sure that we had a MAC address, the device pool, device security profile, and phone button template. Now, all of that is put up in the server. And now we need to ensure that this gets power. How does it get power? Let's click on it. We have to give the IP phone power. There are 3 ways we can power up this IP phone so it can start connecting to our networking equipment. So the first way is a power patch panel, right? As you can see here in this little diagram, we have like a switch, and the switch is kind of connected to another switch, and it kind of patches through power from 2 of those switches to the to the IP phone, which we don't really use too much, but it is an option there to add 2 of those switches, which is a catalyst switch. The second way is a power brick. The power brick, you guys probably use it for your laptop or computer, whatever. We all have it. It's just regular power cable to connect the IP phone to the wall, right? The third option, which is what we use the most common, is power over Ethernet. So we're literally just using the switch, one of the catalyst switch, but a more upgraded one. And we are configuring one of these protocols to say, hey, I want you switch to give power to the IP phone. When it connects through an Ethernet cable to you, I want you to go ahead and power her up, right? And the switch is going to use one of these protocols, 802.3. And again, it allocates the amount of power in watts to that phone, which can be 15.4 wattages, 25.5, or 90 wattages, right? Just again, right to that phone. And the use is through CDP and LLDP. We talked about that in CCNA. So, we learn in the CCNA that CDP, LLDP, we're discovering the network, we're using it in case, there's bad documentation, and we just need to find the device that's connected to the next device, and, network discovery. But, more on the voice side, we're using CDP and LLDP the same way, but more so to discover the device and help travel power to the device. Okay. So it's going to say, hey, this IP phone needs about 13.2 watts of power. And the switch is going to say, okay, boom, I can allocate that much. And now the phone has power. Okay. So the phone has power. The phone's like, oh, I'm alive. Let's go ahead and connect. So immediately it's going to go through its L2 switch and the L3 router. Again, we talked about this in CCNA, but let's go in with the L2 switch. So immediately it knows it's up, it connects to the switch. How do I send data? I'm going to send data through my VLAN. And the VLAN is configured. We have to make sure that we have a voice VLAN, a VLAN that's specifically for audio communication. And then we want a VLAN that is for data. So ensure that, you can get your emails and check your websites. And again, we want to separate that data in our VLANs because we don't want the cable, the network to be congested, right? We want to make sure that traffic can flow easily. We can organize our traffic, separate it, so we know that, hey, voice is coming in here, data is coming in here. If there's any issues, we know exactly how to separate it because, is it an issue with the voice or issue with the data? So that's something that is must. And usually we can tell the data people, hey, can you create a voice VLAN? We can tell them that, or sometimes maybe you're hybrid. They'll allow you to create it on your own. But again, just make sure that voice VLAN is up on that switch. Now, the phone was able to get power, they already know where to send the data. It's on their voice VLAN. Now they're at the router. Looking around, what should I do? The router, we have to ensure that the router has what's called an IP helper address on it. Why? Because the phone now needs an IP address so it can send data, it can send the voice over the internet. Because anything over the internet that wants to send data, you need your address. You need your IP address to send, internet data. And then to get to L2, which is back to the receiver, you have to have your MAC address. So we already have the MAC address. Now we need the IP address. And this IP helper address is going to go in tandem with our DHCP server. It's going to say, hey, I know you don't have an IP address, but let me just get you over to this DHCP server so you can get an IP address and other parameters so you can start transmitting your audio however you need. Okay, so for us, we're just making sure that this IP helper address command is configured and is configured on the sub interface, right? So we only really need to know a few certain commands. Now, to get to, voice, you have to know data. So by this time, you already have, experience in setting up DHCP and IP helper address. So this is a piece of cake to you for this stage, right? And most of the time, they don't want you to do that. So you would probably have to talk to a data engineer and say, can you make sure that this is good? Or you yourself could have access to go into the router and make sure it's configured. And if it's not configured, reach out to someone else, okay? We'll reach out to the data folks. All right, so now we have our IP helper address, our DHCP server. Like I said, now that it has the helper address to route it to the server, the DHCP server is going to give all this information. It's going to give the IP address that the IP phone can have, the subnet mask, which is the network it belongs to, the default gateway, which is a way out of his network. I'm going to give it a lot of parameters, and specifically this TFTP option parameter. This parameter is needed so the IP phone can know to go to the TFTP server next. Because once it gets this IP address and all this other stuff, it's going to say, now what? Now what? You need to go to TFTP server. Okay, so DHCP gave everything it needs. We now can, talk. We now have an IP address so we can talk outside of our network. So the next direction was to go to TFTP. And again, this server is really just to house all the configurations. So it's going to house the things like the phone template, if the firmware is needed, as far as like the software. Do we need an upgraded software? Do we need a specific software? And once the phone connects to the TFTP server, the TP server says, oh, I know your MAC address. Here's the software you need or firmware. Here's your device pool configuration. And here's some other stuff is where you register to start processing calls. Okay. And this is kind of what the TFTP server will look like on our end, which is, again, in the call manager GUI, just clicking some things, making sure it's activated, pressing save, and letting the thing rip. Okay. Pretty straightforward with, TFTP, because we've kind of already did the back end work at number one. So it has all this information. It says, I know exactly where to process my calls. Now it's going to process calls. Now this IP phone is going to register to our call manager nodes, or nodes that are what we deem as call processing nodes. And we talked about that. We talked about our primary node, our secondary mode, and our tertiary mode, right? And that's SIP or SCCP, which we call skinny. And SIP or skinny are call registration protocols that what they do is they allow the phone to register to call processing nodes. Call processing nodes mean that now the phone has a dial tone and it can start calling out or receiving calls if someone knows your number. Now, when you're thinking about SIP, it's a protocol. We look at it and it's new, and we like it because it literally shows you things in plain text. So as you can see, when we go and look at the logs of a audio phone call, it's literally in plain text like this. A CTL file, it will show us the MAC. It'll show us some other things in XLM. XML is almost like a markup language. It's easily read. So, you can definitely, brief up on XML. It's good to have that language on your resume. And it's a simple language. It's not even like, you're really programming anything. Your dial rules, and if it registered to the FTP server, if it registered to the call manager, like it literally tells it to you in plain text. So that's why we like it. And again, this is now your phone call is good to go. You're able to make and receive calls. And from here on out, as the administrator, you're just here to troubleshoot. You're here to troubleshoot if the phone is not registering, if the phone doesn't have a dial tone. You're trying to figure out, what's going on if you cannot, make or receive calls from this point on. And, I put here just some couple things you can do for troubleshooting. On the actual screen of the IP phone, it will show you these states. It'll say that the state is unknown, meaning that it's been more than 3 days since it's been registered to a call processing node. It will probably say unregistered, which means less than 3 days. It'll say registered, means good to go. You're good, to the call processing node. We can start making calls. Or it may say rejected. That means that something went wrong and you need to troubleshoot the configurations. Okay. Before it even gets to that, it will also show you the current phase that it's in. So as we talked about it, we talked about getting the VLAN, and we talked about the IP helper address and the DHCP, and we talked those steps. The phone will display those steps as well. The phone will say, oh, we're getting the VLAN now. Oh, we're configuring the IP helper address now. Like, it's going to tell you which state is it in. So you as the administrator can kind of troubleshoot a little more effectively when you can, probably ask the user, hey, is there anything on the LCD screen? Is it saying that it's displaying the phone is configuring something, or registered or unknown or unregistered? And they can tell you, and you know exactly what's going on and where you should look. Okay. This is very common. It's very common for you to go into get hired because, they have a merger acquisition, or they're moving sites, or just something to where you have to register phones. And what we call that is called MACDs, right? You just, making ads, changes, deletes, you're doing those things. And this is kind of like what you're always going to go through with something maybe not working, and you have to do, maybe reset the phone, soft reset or a hard reset, or you have to delete a file, or you have to do a factory reset right here, where you have to hold down the star key for 3 seconds and then press 1, 2, 3, 4, 5, 6, 7, 8, 9, star 0 pound, right? Like, you have to do these little troubleshooting steps, and they will work. It's just, this is just so common, and you'll just run into this on your daily. And after a while, after like 6 months, I would say that for me, after 3 months of just doing this, it just became like second nature, like, duh, this is what you do, right? So that skill set right there was like, oh, you can get paid $10 more an hour with just that skill set, so, you're able to, get your foot in the door, take what they're giving you as a junior or as a tier 1, and spin that up so you can now be tier 2 in like 6 months, right? Tier 3 in like 6 months. So now you just doubled your income in less than a year, or less than 2 years, right? That's crazy, but it's possible. And it's possible by understanding, IP phone boot up at a high level, so you can get your foot in the door to do these copy and paste tasks. And now you actually have real life experience with a real, big company. And now you can go to the next big company and say, I did this already, and it's really just straightforward. Like this right here, these 1 through 7 steps are in every company. I told you I've curated this right here from my learning, my first job, well, really from like my quote unquote internship that I had, that I gave myself, to my first job, my second job, and even the job I have now, so this is what you're going to do regardless. This is the knowledge that you need to have regardless. It don't matter who you're working for. If you want to be a Cisco voice engineer, this is step 1. Okay. We have 3 steps. We have IP phone boot up, we have outbound calling, and then we have inbound calling. So I'm going to do all 3 of those, so you can have a solid foundation in VoIP technology, and you can just expound off that and literally get you a voice networking job. We are very specialized, and there's not a lot of people with our skill set. People are very general. So if you know this specific technology, you're going to make a lot of money, right? So yeah, this is just part 1. Understand this. I would say if you didn't understand 50% of this, you need to go back to CCNA, because this is nothing but CCNA, but specialized, because you should already know how to configure VLANs. You should already know how to configure DHCP. You should already know how to configure a TFTP server. You should already understand power over Ethernet in a sense, because we did talk about that. And yeah, I mean, if you can understand that right there, then you can definitely hop over here and start just honing in on voice protocols, which we'll kind of talk more tomorrow. Okay. But yeah, so that was it, you guys. Let's see. Okay, we have some people here. You guys can ask questions now, because I'm probably going to cut the video. Actually, let me just go ahead and stop